Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to this Techstrong learning experience brought to you by Lightlytics. My name is Cody, and I'm the host of Techstrong Learning, and we do have an exciting presentation ahead. Before we begin, I have just a couple of housekeeping notes to review. Today's session is being recorded, so if you miss any of our discussion, perhaps you'd like to rewatch or share with a friend. The on-demand recording will be made available shortly after we conclude the live recording. If you'd like to engage with us today, you can do so through a couple of avenues. The first of which is going to be the chat tab, which can be found on the right side of your screen. I want you to use that chat tab for any thoughts you might have during our program today. So go ahead and start warming that up for us now by letting us know from where you're joining. Now, if you have any questions, we'd like you to send those into the Q&A tab, as we're going to be holding those until the end of the program, and that just kind of helps us keep track of them. We do have some handouts that are available under the handouts tab, so feel free to grab as many of those as you'd like. And of course, before we close out, we are giving away 4 $25 Amazon gift cards. So be sure to stick around for the duration of our program today. So the topic of our discussion is detect, troubleshoot, optimize AWS configuration changes. And I'm joined today by Stav Sitnikov, co-founder and CTO of Lightlytics. Stav, thank you so much for joining me today. Do you want to go ahead and get us going?
Thank you very much, Cody, for the introduction. Hello, everyone. As Cody mentioned, my name is Stav. I'm one of the co-founders and the CTO at Lightlytics. And today we'll be talking about how you can actually detect, troubleshoot, and optimize AWS configuration changes with the entire needed context. Before we get into that, let's speak about the common challenges in infrastructure delivery. As you all probably know, there are multiple stages before we actually do a configuration change. And those probably start whether it's a task or a fire drill. They might come from business side decisions, developers, or security. And once we get them as a DevOps, SRE, or a platform engineer, we usually start at the first phase where we need to plan or troubleshoot the configuration change needed to meet the actual requirement or fix a production issue. Now, one of the challenges we have at those areas is the fact that our visibility into the environment and its complexity is usually fragmented. On top of that, architectural knowledge might be siloed between different teams or even team members at scale. Once we actually understood what is needed to be changed, we'll probably go and write infrastructure as code. Whether you use Terraform, Helm charts, CloudFormations, or Ansible, you will go and write this code. The nice thing about infrastructure as code, as you all know, is the fact that we can review it. So you will put a pull request after you probably tested on your laptop or in some side environment. And then during this review stage, someone from your team will actually review it. One of the biggest issues today with infrastructure as code is the ability to predict what will be the system-wide impact of a change. Even when changing a specific small component in our infrastructure, let's take, for example, an IAM policy, we might not know all of the resources who are currently using that or are dependent on that. On top of that, the technologies we have today at hand to actually do it automatically are static code analysis tools, which look at the unit level and create various problems that we will talk about in details further on. Sometimes in fire drills, or if you're not using infrastructure as code, you will probably skip CI. You will do it with a script or a UI change, and you will just push your changes to the runtime environment. Now, once you deploy, day two operations kick in. You need to observe and react to various states of your environment, whether it's a downtime that was created due to a recent change or a resilience problem that arrived, cost issues, compliance and security tasks, and performance issues. Now, all of those might be handled by a different team or by your team as well, or by security or by FinOps. Now, usually at most organizations, if your team doesn't own the entire infrastructure, you will have tasks coming on from SecOps, FinOps, or whatever it is back to you after the deployments. On top of that, application dependencies and behaviors might change and impact various infrastructure-related configurations that we have previously set. Now, if we will drill into that and take 3 examples at hand. First, let's look at what happens when we create a security ticket, when we get a security ticket. what will we do with that? Let's say we got a ticket from security which tells us there is a security group that is open to the internet and opens up SSH. As a DevOps engineer, my first thing will be to see what is the actual configuration of the security group and validate that it wasn't changed, because maybe the SIEM or the CSPM tool that opened that ticket, which usually periodically scans the environment, missed the fact that it was already fixed by someone else. So I will use AWS config, maybe CloudTrail, maybe some other tool at hand. And the issue with all of those is that they are contactless, right? So any ticket that I get, I will need to build the context of that situation in my cloud. I will probably need to use multiple tools or multiple cloud native capabilities to actually build out the context and in order to be able to act on the issue. That might be even like a cost optimization tasks that I got from my FinOps team, because they have seen in their tool that there was a spike or some over payment on a specific service. So I will still need for any ticket to build the entire context. Once I do that, maybe it was a false positives, and then I will just go to my next task. Or if I decided that I can actually fix the issue, I will go and write infrastructure as code, a script, or just use the UI. Now, in case you're using infrastructure as code, and if you're not, I highly suggest you do, because that's the future of cloud and that's the way forward. Let's take an example. So I understood the issue at hand or the requirement at hand and written my code. What will be my next step? I will probably test it. I will try to apply it to some local dev environment, and maybe I will play and look at the plan. As you guys know, Terraform plans can be very big. They miss a lot of data in them, and it's pretty hard to act and review on them at scale. Once I actually did that, and hopefully I totally understood what is going to happen, I push a pull request. Then you can go and drink a coffee until someone else is going and actually looking at the pull request. Now the second person come in and looks at your pull request, and now he needs to build out the context. So he will probably speak with you to understand what was the proposed change, why are we doing that? Let's try to look at other tools to understand what will be the impact. Then we cross our fingers and apply it on. Now, as we all understand from what I've previously said, the tools that we use today provide resource-level information, while context is king. And the question in hand, and this is why we have set ourselves to build out analytics, was what if we could add some context to any operations in the cloud? At a high level, Analytics helps teams to ensure their cloud is configured for success. Usually it facilitates cross-functional collaboration and fosters shared responsibility. How we actually do that? We have built what we call a cloud change intelligence platform. The idea is that we collect data across the cloud infrastructure layers, from the configurations to the actual activities, and build out a unified, deterministic, real-time module of your cloud. By that, our customers are able to detect in real time, troubleshoot, and optimize issues across 3 verticals, which are all dependent on configurations, whether it's availability, resilience, security and compliance, as well as costs. By having that complete view of configurations, activity, all of the changes, and all of the dependencies between them, you can act fast with the entire context at hand. Now let's deep dive and see how analytics can actually help you with achieving those stuff. So the first thing that we usually do when we receive a ticket, as we discussed, is to discover and troubleshoot what is the current state of the environment. Whether it was a ticket where we need to take a specific microservice and allow it to access something in our infrastructure, or we are handling a ticket with a downtime because of some misconfiguration that was involved in our cloud. By using Analytics, our customers told us that they were able to speed up dramatically change planning by understanding the current environmental state, reduce mean time to resolution, and reduce a lot of cycles between both dev and sec by actually executing on changes with understanding the context and not pushing things into our environment and only then getting the alerts and pushing them back. Let me show you some examples on how it actually works. Once you go into Analytics, you can actually see your entire infrastructure. We support all of your AWS organization accounts with cross dependencies in between them. Let me give you some examples. Let's say I got a ticket where I need to take a specific security group and analyze its behavior. The CSPM alerted to my SecOps team that it is exposed on port 22 to the internet, and that's correct. But as I can see immediately, it is exposed on a specific IP. On top of that, I can actually validate with analytics very fast what and where the security is being used at. I can go to violations and see that it actually exposes something to the internet. It exposes this instance. I can see all of the related configuration changes that happen over time and their impacts. We will deep dive into those later on top of the actual traffic that passes through the security group to understand if any traffic actually meets and gets into the instance that is at hand. Another example might be where I get a security task by my security team, where I need to explain them during a compliant process which microservices are exposed to the internet. With Analytics, it's just few clicks. I will select internet and then type pod. Basically, Analytics will look for all of the pods which are exposed to the internet, whether direct or through load balancers. As you can see here, I have a pod here, which is in the one namespace in a specific replica set that is exposed to the internet via an ALB, which was created from a Kubernetes ingress, and we automatically calculate for you which ports are allowed across all of the security groups, ACLs, and the actual network policies. For every component here, you can actually see its live configuration, whether it's the pod, the load balancer, or the security group. So you can actually answer cloud questions very fast with context. The next thing I wanted to show you is how do I handle a task where I get a requirement from a developer that has a running microservice in production. They are planning to upgrade their software version of the pod to deploy a new image, and now they require to have access to a specific S3 bucket. Let me show you how with Analytics you can get the context, understand what is missing, and do it all in under 5 seconds. I will go to the pods, and I will just look for a specific namespace. Let's say that I would like to change a microservice which exists in this app namespace. The microservice is called Terraform. I will select the microservice and set it up as source. The ticket tells me that it needs to access a specific S3 bucket, which is called Terraform. Let's click the find path. What you can see here is that Analytics calculated immediately that network-wise, my pod is able to actually get to the internet. One thing that I already get alerted on, as you can see here, that it is going to do that via a NAT, which means that I might have cost issues if I will actually do that. So I might be required to change the route table to actually meet that and not spike my cost because of traffic going over NAT. Now, as I mentioned before, we need to understand whether it's capable of getting the permissions needed to access the S3 bucket. You can see the service account and the actual role that is currently connected to the microservice. Analytics hints that I am missing an IAM policy. I open up the role, and I immediately see which policy is currently being used. I click on the policy, and I can see that it actually has only access to DynamoDB. Now, I just go to my Terraform AWS console with an exec click to the specific resource and change it to allow the actual ticket and fix the actual problem. The next thing, which is super unique to Analytics, is the ability to provide impact against any change that is deployed to the cloud in real time and provide the entire context around the change. What it helps teams with, first, we automatically alert on issues, and we will talk about that later on. On top of that, you can analyze and track any changes that happen in your environment over time by seeing who did them, what was the change, and what was the actual impact. We are able to alert on downtime issues by looking at the configuration change, the posture change, and the actual data plane activity that happens on top of that. Let's take a look at how it actually looks like. So I wanted to find out a nice use case, and I looked and filtered by timestamp to a specific date. As you can see here, we track all of the configuration changes in real time. And you can see a chain of events that is happening here at the top. First of all, we run an instance, and then we have multiple security group modifications. Then we associated the instance to a specific profile, and then there is the modification of an ACL. Let me show you how Lightlytics actually understand the chain of events and shows you the impact of each change, and that's happening in real time. So here we created an instance. We can actually see with context where it was created exactly. We can see all of the violations that were triggered by this change. We can see that we created an instance which has an unencrypted AWS volume. We have a cost suggesting that you should use GP3 instead of GP2 instances, and various other alerts. The next change that happened here is that someone changed the security group attached to this instance. Instead of serving specific public IP, it just allowed all public IPs to the internet. Now, Lightlytics immediately triggered 2 alerts. Now, as you can see here, those are posture validations, which means that we alert only in case the actual instance has a problem. So based on this configuration change, Lightlytics immediately alerted the customer that it has an Elasticsearch port and SSH port exposed to the internet. The reaction was that someone in the customer team decided not to actually fix the security group, but to handle it in another way, which is a best practice in AWS, to go and close all of the actual SSH traffic, as you can see here, deny all SSH traffic in the ACL of the VPC. Now, what will happen here is that Lightlytics will show me that all of those instances do not have any connection to the internet now on the SSH port, on top of showing me that all of those violations were fixed. And this is the power of context-based real-time events. You can track back, you can get alerted in real time, and you can understand how the chain of reactions in your cloud build up your actual runtime posture. Another unique feature that we allow in our platform is what we call guardrails. The idea of guardrails is to help our customers gain control over their cloud by validating both current state of the environment once Lightlytics was connected and all changes against the actual organizational best practices and the best practices that we provide out of the box for resilience, cost, compliance, and security. Now, some examples for building those out might be setting up, let's call it segmented security rules to validate that only specific microservices, instances, Lambda functions, users are able to access specific DynamoDB. Any change that will break that dependency will be alerted. Another example might be that we want to restrict access between accounts. Let's say I don't want any dev account to be able to access any S3 bucket in my production account. Setting those is super easy, and I would like to show you how it actually looks like. Once you go to our platform, you will be able to see all of the violations in real time, which means that we will show you what is the state across security, cost, availability, and other best practices of the AWS well-architectured pillars. Building a rule is super simple. You just select the type of rule, whether it's path or resource-based. You can select, let's build out an example rule like that. So I would like to build a rule that restricts access between any resource, which might be an IAM user, Lambda function, instance, pod, ECS task, whatever you can think of, between 2 AWS accounts. So I don't want anyone from this account to access any bucket in this AWS account, and I want to restrict this rule to be applied only on buckets with a specific name. So I can set, let's say, this any bucket that contains data user detection in my environment. And that's it. You apply the rule, you publish it into the environment, you will immediately get all of the results against it. You can see an example of how results look like. So you basically get the entire context against every violation that happens in the environment. You can see how it build up and react on it. One of the biggest pains, I think, during the past year for customers around the globe who are using cloud was that our management teams, whether it's finance, CFO, or the C-levels, require us all to reduce costs. The issue at hand is that most cost tools today provide very good visibility for the FinOps teams to see what is the total cost of the account and how much we pay for specific resource types. But us as DevOps engineers who need to actually react on that and find opportunities to optimize or to troubleshoot security spikes, we need to build out the context that our bill or some old cost tool provide us. With Lytics, by the fact that we build out the entire context in your environment, you can act fast on both troubleshooting cost issues and spikes and optimizing your environment. Once you're in the system, you can actually see all of the cost breakdown for your environment, whether it's for specific accounts, you can filter by those, or for the entire bill. The idea is that by having all of the configuration changes over time, the entire data plane activities, and the actual posture at hand, you can understand how the build is built up. Let me give you an example. Let's take this EKS cluster, for example. We can see here that its total cost, the actual direct cost, and the indirect cost. Now, when I click on the cluster, first of all, I can immediately see where it is located, all of the namespaces that run on it, the instances that are part of it, as well as the cost breakdown. Now, as you probably know, EKS is the cluster itself, you pay for it hourly. However, the total cluster cost is built out of all of the resources that have been provisioned or provisioned in the AWS layer or provisioned in my Kubernetes layer. Those might be load balancers, instances, elastic IPs, or even EBS volumes. Lytlitic is able to build out the entire indirect cost and by that show you the total cost of any resource in the environment without any tags, purely looking on configuration. So whether you have tags at hand or don't, you will be able to actually understand the entire cost breakup. Another cool capability, as I mentioned before, is the fact that we are able to attribute any activity in your cloud to any resource. One of the biggest challenges with cost today is to actually understand how data transfer costs build up. Now let's take a specific NAT gateway in my environment and take a look at it. I have this Flowlogs NAT gateway at hand. I can see that it has various usage costs. With one click at hand, I can actually see all of the resources that are sending data through this NAT gateway. As an example, I can see that this resource is sending data to the internet through this NAT gateway. I can see the total traffic volume, and by that understand the correlation between traffic volume spikes and the actual cost at hand. On top of that, you can easily click on the actual flow log and understand the entire configuration that allows that. So for example, if I would be debugging an instance to an S3, and I see that it is passing through this NAT, I can easily find out the route table and go and change its configuration to actually use a VPC endpoint, for example, to reduce this cost. On top of that, as I mentioned, out of the box, we provide best practices for cost misconfigurations, idle, and underutilized resources. The idea is that you can go and actually act on optimizations across the layers of your cloud, whether it's finding out NAT resources that are not in use. And the difference in between idle and not in use in analytics is that not in use, it means that there is no other configuration that is using it. For example, in NAT, it means that there is no route table that is attached to the actual NAT. I can go to the NAT, see who created it if I go to the actual event, and understand how to act. On top of that, as I mentioned, there are many rules for configurations, whether those are finding out resources that are sending data over NATs and not VPCs, VPC endpoints to DynamoDBs and S3 buckets, finding out all of your document DBs, RDS databases, instances, etc., which are actually idle or underutilized, and you get all of that out of the box immediately in real time. As previously mentioned, Lytics is able to actually take all of the activities in your cloud, whether those are flow logs, access logs, or IAM activities, and attribute them to the actual posture, whether those are specific configurations or specific services. What it allows you to do is to understand how your cloud network and IAM behave against the configurations. It allowed our customers to investigate availability, security, cost, with the actual data to act on. As well, Lytics automatically alerts on anomalous behaviors such as unexpected traffic volume spikes, unexpected errors, whether those are sudden rejects in flow logs or in IAM access. As I mentioned, we attribute immediately all of the traffic to the actual resources in place. You can group and filter by anything in your cloud. You can actually even look for flow logs based on tags, specific locations such as VPCs, accounts, IPs, etc. We allow the ability to automatically detect in one click all of the traffic which is going cross-region, cross-account, cross-AZ, and even public to public IP traffic which is going out of your cloud and harpening back into your cloud. That will allow you to reduce cost by understanding how your application behaves on top of your configuration state, so that in one click you can see all of the traffic that goes across AZs. You can group it so that you will get less results and go and act on it. So I can see that this instance is sending data to a load balancer, which is actually not in the same AZ. I will be able to click on the path, go troubleshoot, and change the way my infrastructure is configured to actually reduce the cost of data transfers. As mentioned, we track all of the activity in the cloud as well. IAM activity for users, instances, Lambda functions, etc. You will be able to see any action that has been taken in your cloud and act on it. As well, we look at get objects, for example, so you can see here a specific bucket that is being written by this specific role from this specific Lambda function. I can look at the bucket and actually see all of the activities related to it. I can see there are multiple roles which interact with the bucket, whether this role, which actually gets objects from it, we have another role that gets objects from it, and by that I get the entire context between configuration, current configuration, events, the changes that have happened, the activity it is placed, and the actual cost of any resource. You can build out saved views to actually go and detect various application issues. For example, a user might complain that he is missing, that he's having issues with accessing some specific service. You can immediately go here, filter on the specific user by selecting its identity, then just filter on any errors, and you will see the actual errors he is hitting to get the resource and for which role he is using that in place. Now let's talk a bit back about the build stages. Infrastructure as code has been with us for multiple years now, and it is being widely adopted. But still, the way that we treat the process of writing the code and deploying it to production is being tested in a unit level. And what do I mean by a unit level? When we run a Terraform plan, for example, we will get an output of the change of every resource at hand. As you know, you will probably be missing context, as well as having a loss of data because of the fact that how Terraform built out the plan. Then you will probably do some basic testing to see that the apply actually works on some side account. You will try to do integration testing, but you will miss the actual context on your environment, and understanding all of the dependencies in your account might be hard, especially when your infrastructure is not entirely being built out of Terraform. I might have parts of my infrastructure written in Terraform, while other parts have been previously deployed manually or with scripts. Now, when I change a Terraform resource, this resource might have been used by another service, which is not even part of my Terraform state. And now understanding this entire picture is hard. But how do we actually act on that, and how do we use the fact that we have now the power to write code and test it before deployment. So with Lightlytics, you can shift left with the entire runtime context on your environment. As stated before, we hold the entire runtime context on your environment in real time. Our simulation engine is capable of merging the current state of your running environment against any Terraform code proposed change. And by that, help you determine how your cloud is going to be impacted, as well as check all of the best practices for cost, security, compliance, resilience, and detection of availability issues. For example, you are changing a security group. This security group is actually being used by another team where they are serving traffic on the specific port that you are changing. Now, you might create a downtime due to that. With Lightlytics, we can alert on that because we understand how this change will impact the running environment at place. So don't scan, simulate. What you can actually do with Lightlytics in the simulation phases, currently we support only Terraform, but we are planning to add various other infrastructure as code platforms as well, is the ability to check any pull request at hand against the environment. Lightlytics will be able to connect to any of your CI/CD systems, whether it's GitHub, Terraform Cloud, Jenkins, Atlantics, etc. And then against any change, we will intersect the change, simulate its impact, and push back a comment with the entire change at hand and a link to our system, which will help you speed up the IAC review processes, eliminate misconfigurations, automatically validate your organizational best practices with the same architectural standards that we check in real time. So you need to set those standards once, and they will be checked both in real time against any change coming into the environment and against your Terraform changes at once. Let me show you how it looks like. Once a change comes in, we show you, similar to a Terraform plan, all of the resources that are going to be changed. The ticket that I got and was asked to do is to take a specific microservice and allow it access to S3. What I basically did is that I went to the role that is used by the service account, and I created a new policy and swapped in between them. The new policy at hand actually has the allowance to get objects and list S3 buckets in my environment. Till now, everything is as usual. As you can see here, Lightlytics is able to show me how my posture will be impacted in the runtime environment against the change. I can see here that I'm going to lose connectivity to the AWS API service for EC2, and this is the actual change that I did, as well as I will get those two microservices access to all of those buckets. I can actually see here which microservices it is. It was actually already deleted because it's a simulation, but never mind. On top of that, we check all of the violations against it, all of the best practices. Now, think about it. I just did a change on an IAM policy. The system automatically detected which other resources that are running in my environment are going to be impacted. And on top of that, it detected stuff that I probably didn't think about. For example, it detected that this microservice is now going to have connections towards S3 buckets via NAT gateways instead of VPC endpoints. So as you can see here, this is my pod. This is all of the buckets. Those are the changes that I've done. I've modified the role to use this policy, and I can see that it's going to use this NAT. Now I can easily go and act on it. I can see which route table is in place, click on it, see its current configuration state, which doesn't have a VPC endpoint, go and fix my Terraform and add another modification to this route table to not have high spikes of cost by sending data over NAT. Now, this is how we created context out of a simple configuration change against the running environment and detected both cost issues, security issues. As you can see here, the system alerts on the fact that I have over permissive S3 get object permissions. And all of that happens in seconds. So it's not like you need to push the pull request and wait for too long. Another thing I wanted to mention, everything I just showed you with the simulation, you can actually do it in your IDE. So you can run your Terraform code, run our self-hosted publisher, and just from your CLI, get the entire result of any simulation, get the link to the actual change so that you can do it both at the testing phases where you are still developing your infrastructure as code, or against your pull request by hooking the system into your CI/CD processes. Another feature that I wanted to mention was the fact that we are adding everything I just said, the events-wise, to the Kubernetes layers. I just throw it out as an example. So someone came and modified this deployment in my environment. I can actually go and see what was modified. We have changed the version and are pulling a new image from our ECS. Lightlytics automatically builds up the entire tree and dependencies of the changes in Kubernetes. So from this modification, actually a new replica set was created, a new pod was created out of that. Our endpoint service was changed to actually being able to serve traffic. By having this endpoint change, EKS automatically went and changed my target group. Now I have this new pod in place. I can actually look at it. I can actually see how posture is going to look like for this pod. I can see if it has any violations. The only violation I see is that it is going to be exposed to the internet via load balancer, which is probably what I wanted. If not, I immediately get alerted on that. And this is how you can actually build context across both your AWS layer, your containerized layers, and in between them, having both configurations and data at hand. Now, as I've been talking a lot about context, one of the nicer thing that we can do by having Lightlytics is the ability to enrich any CloudOps tools that you use today without any integration. We have developed a unique solution which integrates into your browser as a Chrome extension and monitors the entire activity on the specific URLs that you want. In my case, I allow the Chrome extension to look at my Datadog. What it's able to do is to track and understand whether there are resources in place that are part of your environment. Now here I can see that Lightlytics understood that this instance is part of my environment. It doesn't have any violations in place. I can actually now, with one click, get the entire context of this resource at hand. So first of all, I can see that this resource was already deleted. My Datadog is looking at a week of data. The resource was already deleted, so it's good, right? I don't need now to go and debug this memory issue because the instance was actually already deleted while somebody opened the task on me. Secondly, I can actually validate that it was terminated by seeing all of the configuration changes. You can use this tool to actually understand the posture of every resource, troubleshoot faster and better with any tool that you have in hand today. Cody, I'm ready for questions.
All right, Stav, thank you so much for running us through everything. And you said the magic word. So everyone send in any questions that you may have for us, and we're just going to start taking them from the top. So it looks like our first question asks, how do you approach detecting configuration changes in AWS?
That's a great question. We use CloudTrail with the CloudWatch rule to actually enable us to get the real-time change. Then a Lambda function forwards the configuration change into Lightlytics, whether it's over the internet or over private links. We have a relay network across all of the AWS regions worldwide so that you do not pay data transfer costs sending us CloudTrail data, flow logs, IAM logs, or whatever any other log in your environment.
So are there any specific tools or services that you use to monitor those configuration changes?
We use AWS Cloud Native Detection System, which is CloudTrail, and we get this data through CloudTrail directly to us. For Terraform changes in pull request stages, any CI/CD, whether it's GitHub, GitLab, Bitbucket, Atlantis, or any other tool such as Terraform Cloud, etc.
This question looks a little bit specific, but is there a preemptive component here to predict before deployment?
Yes. The preemptive component is that on every pull request, if you are using Terraform, we currently support only Terraform, before deployment, we are able to actually show you what will be the impact of the entire change against your running environment.
So could I integrate Lightlytics into my DevSecOps CI and achieve proactive security?
Yes, definitely. Part of the use cases of using Lightlytics is that we provide you the actual policies for both security, compliance, cost, and availability, which basically cover the entire AWS well architecture framework pillars, and you can do all of that as part of your CI.
Awesome. So which web apps can the Chrome extension be used on? Datadog, AWS console, anything else?
So basically any tools that you might think of. It might be Datadog, any other APM. It might be a security tool that looks for your like CSPM, CWP, vulnerability scanners, etc. The idea is that as long as we are able to detect AWS resources on the screen, we will be able to attach the entire context at hand natively in your browser.
Perfect. Wow, we went through those questions really fast. So everyone, please do send in any more that you have. Okay, what are some compliance use cases at build and ops?
Awesome. So for compliance, as you know, compliance is built out of three pillars. You have the security, the entire cloud security, whether it's CSPM, CIEM, both for the actual machines, the users, and the entire best practice, as well as part of compliance is how well your system is resilient, how well you are cost optimized. We take all of those and push them against the CI state. So you can basically validate that you are compliant, that your changes are compliant at both build and runtime against any change. So that you will be alerted if you are not compliant, not by some periodic scan, but on the actual change that broke your compliance, whether it's in build or runtime.
Do you support any APIs and how will it help for SOC compliance and security audits?
Awesome. So first of all, we support API. Our entire system is built out of GraphQL that you can hook in. We have pretty nice documentation around that. We have already many use cases with current customers who use our system to actually enrich their own homegrown tools, right? Many companies who have been in the cloud for a long time have built a lot of homegrown tools, and we help them with actually enriching their tools, whether it's through the APIs or just using our Chrome extension on top of their homegrown tools at place. And what was the second one?
Sorry, and they asked about how it would help with SOC compliance and
Okay.
security audits.
So out of the box, we provide all of the needed checks for SOC 2 compliance. It will help you basically understand your compliance posture. I didn't show the entire system, but there are dedicated screens for seeing the entire compliance, how well you are met, and understanding what are your gaps and whether those are actually required to meet the SOC 2 compliance. As well, part of SOC, as you all know, is having a resilient system, being able to track all configuration changes and attribute them to the actual people who change them and understanding their impacts. We provide all of that with our events capabilities during compliance audit, and this is how we actually test our SOC 2 and various other AWS requirements as part of being a partner, is that with Lightlytics, you can actually go and show the auditor what is your state and how you can actually understand your cloud very well. So passing a compliance with the system usually is an easy thing to do. We have huge companies from enterprises using us for compliance purposes, as well as very small startups with up to 50 people using the system. One thing that is important for me to mention is that we have built the system for cloud practitioners. We have never sold it through the CISO or the CTO or the CIO. Usually, our customers are the actual engineers on the ground, whether those are DevOps, SRE, platform engineers, or SecOps engineers, who come check out the system and give their management a tool that can actually help the entire team collaborate and share the responsibility amongst those layers of cloud.
Awesome. How can somebody get started? How can we start testing?
That's a great question. So Lattice can be tested in two ways. The first one is the entire platform, the unified platform, which will cover your availability, security, compliance, and cost needs across your entire cloud. You can go to our website at lattice.com and start a free trial for 21 days. If you want to check out a specific component of Lattice, you can go down to our dedicated solution website, whether it's TF-Rails, which will allow you to only get the component for the Terraform change intelligence, Cloud Rails, which is more focused on SecOps, or Costo, which is purely focused on cost. Even if you select any one of those and they have freemium tiers in them, you can always upgrade easily to the full unified platform without any further integration needs. Any other questions, Cody?
So at this moment, I'm not seeing any, but I'm going to stall for just a couple minutes to get us a little bit of time. But while I announce a couple of gift card winners, I'll go ahead and roll an offer out on the screen. So to everyone who's joined us today, I'd just like to remind you that our session has been recorded and will be sent to you via email shortly after we conclude. Or you can also find it living on the DevOps website at devops.com/webinars, and be sure to look in the on-demand section. The four winners of our $25 Amazon gift card drawing, they are Mateo T, Hiram W, Carol B, and Ranjan K. So to our four winners, keep an eye on your email inbox to claim it. It should make its way to you in about 48 hours. But if you don't see that gift card, just check your spam folder in case it gets filtered out. All right, Stav, we've got some questions. What AWS, Azure, GCP security services are you pulling data from?
That's a great question. First of all, just to make everyone clean on the table, we currently support only AWS. With regards to the actual data, we do not pull data from any security tool. We pull only the configuration state of your cloud and the actual activity, and we build out the entire unified module across the layers. We do not want to be dependent on anyone else, and that's why we make sure that we build a unified model which will be able to provide you the entire context by ourselves.
Awesome. Well, Stav, is there anything? How can we get in touch with you and your team?
That's a great question. You can reach me out at stav@lightlytics.com directly. I usually answer emails pretty fast. And that's, I think, the best way to reach us out. Or you can do it through the website. There is a contact us form, or just start a trial. I think that's the best way for you forward.
Awesome. Well, do you have anything for us before we go off the air? Any parting words or anything that you feel we need to know?
I don't have anything in particular. I do want to say thank you for everyone who joined us today. I hope I didn't waste your time and you at least learned some new cool technologies. And I hope that you guys go and try it out. That's the best way for you to actually experience the product.
Awesome. Well, Stav, thank you so much. And to Erdem, who's been on the back end and helping us answer some questions, thank you for all of your help today, too. Stav, thank you so much for being here.
Thank you, Cody.
I would like to thank Lightlytics for sponsoring our program and bringing us this content today. And to everyone who's joined us for the past hour, thank you so much for being here. We really value your time, and we would like to hear your feedback. So as soon as we close out, there will be a survey that pops up. Let us know your thoughts on today's program, or if you have any suggestions for a future program, please do let us know. Otherwise, we do hope to see everyone at a future Techstrong learning experience. Have a great rest of your day, and you may now disconnect. Stav, thank you so much.
Thank you. Have a great day.